Hi everyone, again, welcome to my live stream. So today, let me just first welcome to my live stream. Today, the idea is to present. I'm streaming to multiple targets, destinations. So, and I'm listening to stuff. So I'll just try to mute everyone. Okay, now I think it's fine. So let me try again. Hello, welcome to my live stream. Today the plan is to present and code everything related to the fraud detection. So it's actually not that deep inside the code, even though I might do a bunch of stuff on the code side, since we have a couple of demos which still have to be polished. So yeah, it's gonna be a combination of presenting these demos and explaining what different types of fraud are, and also a little bit of coding, hopefully. Yeah, as always, like, share, subscribe, and let me just recover these. If I run this, yeah, post your questions in the chat as well. Yeah, I can address them immediately, and that's very cool. Even though I have to figure out how to see all these questions because I'm streaming to 5 platforms. So today we have YouTube, LinkedIn, Twitter, Facebook, and Twitch. So I have to find a way how to see the questions immediately. Let me just go to here. 2 seconds, seems like it's working. Amazing. Everything is okay. Facebook, except Facebook. I'm not sure about Facebook. Yeah, it's also working. Yeah, here and there I'll try to watch for comments. Oh, YouTube. Boom. Yeah. Okay. I think it's fine. So let's get started. All right. So fraud detection and fraud in general. Let me switch to this view. What is fraud? So there are a lot of definitions, but yeah, in general, fraud involves whenever people want to gain illegal or unethical stuff from various types of activities. And there are many types of fraud. I just went to Investopedia, but this is more or less all about financial fraud. So there is credit card fraud, insurance fraud, wire fraud, invoice fraud. There are many different types, but there is also fraud in other industries, for example, healthcare. I actually stumbled upon this cool blog post on Towards Data Science, and it's about provider fraud. So that's a fraud in the healthcare industry, and hopefully last part of this live stream I'll try to load this dataset because dataset is super cool. It's on Kaggle and it has a bunch of stuff here. So beneficiary data, pet data. Yeah, anyway, there is a bunch of these data points here, so I'll try to load this somehow into Memgraph and run some analytics, probably something similar to this blog post. This blog post is based on, I think, NetworkX. Yeah. All right. Anyway, let me jump into the fraud, into the card fraud actually. So on the Memgraph GitHub repo, there is a nice Memgraph GitHub organization. There is a nice repo explaining what's the card fraud. Essentially, it's a very simple idea. So there are 3 types of nodes, 3 types of entities in the system. It's a credit card, it's transaction, and a point of sale device or anything like that. And as you see, transaction is using some particular card, and transaction is done at POS. And let me now, so this demo is actually ready, and it can be easily run. It's packed inside it's packaged inside the Docker container. So I'll zoom in a bit. This, yeah, hopefully this is big enough so you can see. So under card fraud, there is the whole repo, and I already run the whole build. It takes a lot of time, but once you install Docker and Docker Compose, you can just run Docker Compose build, and that will build all the required images. And Docker Compose up will just start the demo. And yeah, it's started and it's in debug mode, which is fine. So we won't run that in production or anything like that. And just a comment here. So there are 2 containers. One is Memgraph and one is the actual application. If I switch back to the browser, I had this here, but that's from before. I was just testing. If I rerun it, so this demo is now available. Here we just have a dummy dataset which is generated, and if we generate another transactions in the system, then we can also like run detect fraud. And if you can see, here we have a point of sales and transactions, and we have also these number of connected frauds for these 3. But I'll explain that in a bit. So this is the actual graph explaining what is. I'll explain in a bit what is going on. So as you can see here, there are it's fine. So if you can see here, there are many transactions going on in the system, and an interesting thing here is that these 2 transactions, 44 and 49, are marked as fraudulent, and they were done on POS 5 and POS 8, but it's not known actually where the identity was stolen, and that's a question that has to be answered somehow. How Memgraph can help in the whole thing is if you trace back these from the compromised cards. If you trace back through the graph, you will encounter a point of sale which is common between these 2 transactions. So if you go back, traverse a graph, you will reach POS 17, and that can be a regular graph traversal, and that POS is shared between these 2 cards with these transactions, and that point of sale is a candidate to observe, is it compromised or is it all good with that point of sale. And yeah, once you detect a common point of sale, someone has to go and check what is happening on that point of sale. For example, in this case, let's say someone takes your card, and then transaction 44 could be he's buying a boat or something like that, which is not you, but you will mark that transaction as mark that card and transaction as compromised, but then the bank or whoever owns is in charge of the cards has to figure out where the identity has stolen, has to run some fraud detection analysis. And yeah, by applying graph algorithms, it's possible to get a better insights how and what actually happened. All right. Let me check the comments. Seems like we are good on here and here. This is also working. All good. We are on air. All fine. Connection is excellent. Nice. All right. So this was easy because demo is in the demoable state. Let's now switch to something more interesting and challenging. Okay, we don't need this, we don't need this. There is also a demo called insurance fraud. This is a bit more complex because it has much more complex data model. And basically, this demo here has a bunch of stuff because it's a lot of data in the system, and we need to load all these different data points, which are usually in the format of tables and not that well connected between themselves. And here, this demo has actually like a generator for the data set, and then a way how to import it to the database. But we have to make that somehow loaded inside Memgraph. Previously we used S3, but my goal today is to actually load that locally from local files. But since these are tables, we will represent these tables as Parquet files. So first Parquet files will be generated, and then we'll try to import them through GQL Alchemy, which has these transformations, which are very handy to transform tables into a graph. But I'll try to run it, and I haven't done that so far, so it might be time consuming, and I'll spend some time on discovery how to actually do it properly. Anyway, but sorry for not explaining in the first place what this type of fraud is. So in this case, we are talking about insurance fraud, and insurance fraud is also interesting because you have many entities, many people in the system who are actually trying to like fraud the system. So for example, you have a car accident or something, or a car, and you want to make some claim for the cash or something to get from the insurance company, but your claim is fraudulent, and then you have to figure out how to actually detect that the claims are fraudulent. And people are doing various stuff, so you don't have a clear way how to detect the fraud by simpler rules. For example, if the amount is higher than something, that's not super applicable and super useful, because that type of rule is usually very easily like there are many edge cases, and people can fraud that system easily. Usually these days people are running some machine learning models to run to detect fraud. An interesting point is that these machine learning models can be greatly enhanced if we add graph features into them. So for example, very simple stuff like detecting fraudulent activities in the graph. Once there is a data model and a graph, then you can run some like basic traversal queries to detect if is there any fraudulent activity in a subgraph or in the neighborhood of a graph. Or you can add more advanced features like PageRank, community detection, and other graph algorithms. And I think this blog post here, this approach here is also doing similar stuff, because they talk about author Lina talks about centrality, PageRank, and even Louvain is the clustering algorithm, and that's used for to get some features which are used in fraud detection. Anyway, so basic idea is to load the data, somehow model it as a graph, and then run some graph algorithms like PageRank that can be incorporated into the machine learning model. I won't be that focused on the machine learning part, but yeah, that's also maybe in some future videos I'll cover that as well. Okay. Yeah, I have to find a way how to better get these comments visible, because there is a lot of platforms, so I need some. Yeah. All right. Okay, good. We don't need this. This is fine. Okay. Let's go back here. Let's stop here. So this was the card fraud. Hopefully is understandable. There is a GitHub repo, so you can start, you can comment, you can fork, you can do whatever with that. Let's go back to the insurance fraud. This might be a bit more challenging. Okay, so we have this. Okay, let's start Tmax as usual. Okay. Insurance. Boom. Okay, nice. And we readme. Boom. Okay. Dataset. So for this type of thing, for this demo, we actually have the dataset generator. So I'll try to run this. There is a poetry file, but I don't have poetry set up. SVE3 is start virtual environment, so alias SVE3. If you see this, that will start a new virtual environment. AV3 is just activate that environment, so it's fine. And if we run cd dataset and we run Python data generator, no module date util, yes. Let me try to install the Py project. Poetry install. No module name poetry console. Yeah. Let me debug this. I'm usually using plain pip, not the poetry, and poetry is always complex for me, but what is this? I've installed poetry by running pip install Python poetry, but that obviously didn't work. Doesn't work. Let me try to run this because I haven't. Yeah, we have all these things. So if I run poetry install again, no. Yeah, this doesn't seem to be the right. Anyway, I'll try to install this in the regular way. So if I run back dataset, if I do pip freeze here, nothing is here. Okay, which is nice. So I'll just Python dataset and then data generator date-util pip install Python date-util. Okay, if I run again, faker. So faker is also package we're missing. Nice. Pip freeze. Nice. And then run it again, faker vehicle. Let me move myself here. Faker vehicle. This is fine. If I run this again, numpy. I'm brute forcing a bit the pandas. Okay, and now, yeah, I need some arguments. So if I go back here, yeah, this is a bit too big. Hopefully this is fine still. So data generator, we have two parameters. Total families, total incidents. Okay. If we do here 100 and 300. Okay, we are still missing some stuff. So pip install pyarrow if fast parquet. Okay, git st, that's fine. Sorry, no. Boom. Okay, now we generated the dataset, which is in parquet format. Hopefully, ls dataset data. Nice. Here we have parquet files, which is amazing. Claim. I'll try to explain what all these different files are and all these entities, but a bit later. What I want to do now? Pip freeze. Okay, now we have these dependencies. I'll just start another co-b. Let's say local import. So this is git checkout -b, which means branch. So I'll create another branch, and here pip free txt. Okay, got requirements. Okay, now we have these requirements which are kinda okay. We'll see if everything will work. Okay. Let me just create also immediately the repository, the branch and PR. So we have that file. Add import from local files. No, actually, I'll. So git -me polish. The branch is now called polish, so it's a bit more generic, but anyway. So we have that file, git commit -mo, which means message, add requirements. This file might be deleted later on because of the poetry, but since I cannot set up the poetry correctly, I'll just skip that part for now. Do not waste time on that. Okay. Now we added I'll create a draft pull request with this. Add some polish. Super simple for now. Polish, boom. Draft pull request, boom. Okay, nice. Now we have the draft pull request on that side. Let's go back. Okay. Since we have, so it's usually these days data scientists usually use these Parquet files to store data. They are very convenient to move data around, and I know they are used quite often in different workloads and different use cases. So let me just how I can open this file. Viewer. Is there some convenient viewer to see these files? Nice. What is this actually? Visit data. Visit data. Let me try to install this. Visit data. Boom. And what does it says now? How to open Parquet file. Interesting. So they go a bit bigger. I think it's fine. Under previous version. What? Where is the? It was. For example, here was. What's gonna happen if I run this? And now write dataset data address. No module name pandas. I have to install pandas, but not here. Pip install. Okay, if I run this now, we have the same issue here. Pip install by arrow. I'm just installing locally these files by arrow and fast parquet, because now this nice. Okay, now we have and all the Vim stuff are working. All the Vim bindings. This is amazing. So okay, we have a street name, city, country. If I click here under if I go back, Q is quit. I'm super happy because of this. So VD is VisiData, which you can open, where you can open these files. As you can see now, that's loading. So we have address ID, street name, city, country, and with standard Vim bindings JK, you can go up and down. If you open one of them, you will get one of these item text. That's type of the, and with Q, you go back. Okay. Nice. Very nice. And let's open something else. For example, we have a vehicle. So these are all generated data points. It's completely random. But okay, we have some real models here. So vehicle ID. Let me. There has to be a joint table, some incident individual. So incident individual and incident parquet has incident ID, accident date, police ID, address ID. Incident. Okay, we have these files here. Okay. Incident. Incident and individual. And incident individual. So int ID, and then there is data about that. And what about incident individual? Individual. So this is a joint table which says incident ID. So yeah, this will be, the problem is when you have two entities which have relationships between them, then there has to be a joint table. So this is incident ID and this is individual ID. Nice. Okay, now we can see these data points, which is amazing. Because the problem is, sorry, I haven't explained that, but the problem is that these parquet files are binary files. So if you want to open them with a text editor, dataset data address. You get a bunch of random stuff. So no go. There has to be a viewer for that. But yeah, visit data is a nice thing to have. Okay. What's next? Let's go back here. So the problem is that we cannot import these easily because config is we have a bunch of tables and now we have to create a graph out of them, but there has to be something which will specify how these tables will be translated into a graph. And here there is a config file which has a certain format. So indices means that graph indices will be created based on, for the address we'll have added ID. For the claim we'll have basically all these ID fields will be indexed. Name mapping is individuals label. So for individuals, let me just, for individuals, for individuals we'll have label individual, This will specify how labels will be added. One-to-many relations, address, individuals foreign key address ID lives in. So this is one-to-many. Sorry, how is that? Address is just empty. Individuals has foreign key. If we go here and go under individuals, oh sorry, not that. There is the address ID, and that will specify which type of, which ID in the address table we have to look up to get data. So that's fine, and that's specified here. So individuals have foreign key, which is address ID, reference table address, reference key address ID, and labels lives in. Okay, so individuals have foreign key, some foreign key policy have some foreign key, a lot of them. Claim has something, incident has something. Okay, these are all simple, so we'll just create these nodes out of the whole thing, and we have many-to-many relations which are here. Okay. So sorry, many-to-many. So incident individual, and we have these foreign key too, and then the same thing. Okay. I think this is quite self-explanatory. Let me know if I should explain something more on this side. Okay. We have data generator. That's done because we have data here. That's amazing. That GSS, so under Memgraph Lab, we'll apply this style, and hopefully we'll get some nice styling in the of the graph. Table generator, I think that's used just under data generator, so we don't need that. Yes, that's fine. And insurance, what do we have here? This is also just for the data generator. So essentially nothing here to do anymore. Config, we have stuff here. Okay, and now we have to actually import these somehow. But in the GQL Alchemy project, we have a way of importing these things. So when you have a bunch of tables, then you have to specify these mappings, and GQL Alchemy should help you import that type of data from anywhere. Okay, So I was searching here. And there is that class called CSV. As you can see there, you can import from S3, from Azure, from CSV, from ORC, whatever that is. But here, Parquet local file system importer. So full path to directory, data configuration for translation, connection to Memgraph optional. That will done on the fly. And we also need Memgraph to be up and running. Okay. Let me do that by doing the same as we have in the card fraud, because default workspace card, nice, nvim docker file. So here we actually don't need this because we just need docker compose, because we just want to run Memgraph in the platform mode, and then later on we'll append more stuff. Okay, so let's go back here and let's just move cp card fraud docker file. Let's move it. Let's put it, no, docker compose. Let's put it here, and once it's here, we don't need this part, so that we'll reuse that later on, just to run docker, just to run Memgraph. So we need to run Memgraph because the script has to connect to Memgraph. So if we do here, so we do have what do we do here? CMD, let's say code 3 is run insurance fraud, and we run docker docker compose up. Okay, now we should have Memgraph running. Okay. On the port 3000, yes. That's actually old Memgraph lab in the Memgraph platform. I think I have an old Memgraph platform. Okay. Ooh. Not good. We have to fix this probably. But for now, we just need Memgraph lab, latest Memgraph lab 221 Linux download. This is a bit, whenever I do stuff, seems like our seems like our website is not working. That's a problem. Uh-oh. huge problem. Something is flaky on the web. I've downloaded stuff, but seems like we have some issues on the web. Okay, I'll report that to someone. For now, just give me a second. Quick pause. I'll be right back. Let's close this. Sorry, I will just start loading this. Yes, I have a like super old version of Memgraph Lab here, so Memgraph Lab. Yes, this one is the one, and we can quick connect because we have nice. Okay. This is lab. We have Memgraph up and running, and we can use it. Yes, I need some music for situations like this. Okay, let's get back to this. We have lab, we have that. Let's go back to here. So Memgraph is running. We have stuff here. We have this. Okay, and we need GQL Alchemy. We need GQL Alchemy because we need this Parquet local file system importer. Okay, and we need to activate it again. Pip install alchemy. Boom. Everything is working. It would be so good if I could see all the comments in one place, but anyway, it is what it is. And what about Twitch? Twitch is doing okay as well. Amazing. Okay, we have GQL Alchemy now, but we need like main file. Let's call it memgraph.py for now. Okay, and then how to load these things? Loaders. That's under loaders. Ah, this is really big. GQL Alchemy loaders. And then I think from GQL I think this should be fine. Print la 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 just to have something. Python. Yeah, we have that loaded, which is amazing. Now we have to importer equals parquet local file importer, and that has path. We'll do just dot dataset data, and then dataset data. Yeah, that's the path, and data configuration is under config XML. Path data configuration dot okay, importer init. And how to run this now? Now it's gonna be interesting. Okay, init load configuration. String object has no attribute get. Where is that? GQL Alchemy. Why this doesn't work? Because I'm not v3. Nice. A bit smaller to see what is going on. 640. Data configuration. This is not. I see. It's name mappings. I have to provide. I have to provide string. So init data configuration, data loader. Path. Data configuration is just passed to this, and then data configuration by arrow importer. By arrow data loader. Yeah, what is the configuration for the translations? I think we have to load the whole file. We have to load the whole YAML file instead of just a path. Yeah. Okay. How to do so? I think I don't know immediately, but we'll figure out. Let's go back here and let's go here. Don't need this anymore. Let's Google a bit because load. We need quickly. This should be simple. Yeah, as stream YAML load. Yeah, we need this. So I think this is also a library. Open config YAML. So here. F parsed YAML. We need this. Boom. Stream. Here we need F. Let's just comment this out for now. Yes, because we need pip install YAML. YAML. PyYAML, yeah, PyYAML. Install Py. Okay. Boom. I think this is it. So okay, YAML. Yeah, we installed two different things. So pip freeze or shit. Now we got a bunch of stuff. Yeah, okay. Okay, but now this should work. So we have parsed YAML importer. Translation data configuration translation mappings. These are essentially translation. These are essentially translation mappings, and we don't need this. We need this. Let's remove this translation mappings. This should be the magic. Boom. This passed, so hopefully we have some data inside Memgraph. Or not quite. Nope, nothing is there, but we created the object, which is fine. How to run this actually? So we have file extension Memgraph by arrow. This is this is also just inherited by arrow init table to graph importer, also just the in constructor. Table to graph importer, create trigger, init translate. There is translate drop database on start true. Okay, that's the method we need. That's the method we need. Translate drop database on start equals true. This should be the magic. Data loaded. Okay, seems like we have done it. Boom. Function date doesn't exist. This is a problem with Memgraph because we have old version of Memgraph. Okay, let me. Yeah. We got some stuff here. Graph schema, generate graph schema, address. We only got partially data in. Okay, what's next? We need to download Memgraph. Platform will be kicked out. Okay, docker hub, there is docker hub. Memgraph. .231 is the latest one, so we need memgraph/memgraph 231. So if I just do this, let's stop this here and go back to the docker compose 231. we don't need this because, and also entry point is wrong because that's for the platform. If we run build, skipping, no. Yeah, we need to get some cleanup done here. Rama all something like this is required. We clean now. But we can also do the same here. Aha. Two, 6, 8, 86, 2. Yes, that's kind of problem. And yeah, that's the version which is used in multiple. I think we have to remove memgraph platform. Yes, and now use this. No. But why this doesn't? Memgraph uses an image skipping. Because sorry. I was completely wrong. So because we have the image that's actually pulled when we run things. So let's go here, Docker compose up. Yeah. Now let's run the whole thing. We're gonna have to go back here, loaders. We don't need this anymore. We don't need this. This is like a temp file. Okay, nice. Boom. Okay. Okay, we have the latest memgraph, and now this should work. So I think date is a function which we added in, I think, 2.1 or something like that. And GQL Alchemy is using that and I haven't streamed for a while, so if we go to lab, yeah, we already have more nodes than we had before, so which means great stuff. Nice. Okay, now we have the full data model. Incident claim. Doop, 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 doop. So policy insured vehicle. As you can see, it was quite easy to load all that with GQL Alchemy. So essentially, just to repeat, so whenever you have a bunch of tables, you just have to create that mapping, and mapping is not that that complex to write, because it's essentially a YAML file which just specifies what is what. And as soon as you have this, you can get any Parquet files because they are in tabular format, so it's quite defined. Parquet is also very good because it one of the guarantees that Parquet provides is that the data format will be stable across many years, so they won't change the actual format. So as long as you have Parquet files, it's super easy to load them. It's guaranteed that you will be able to load exactly the same file throughout many years, so it's amazing. Okay, that's about it. Anyway, let's go back here. So a bunch of stuff, but now we managed to load the whole thing, but to actually run some stuff, we need, I think, the notebook. So notebook is done here. Jupyter pip install Jupyter once install launch Jupyter lab. Pip install Jupyter lab once install launch Jupyter lab. Okay. Now this will install crazy amount of dependencies. Jupyter lab. Okay, we have the Jupyter. Shift enter should run this. No module named .env. Okay. What if we just do this here? Yeah. Okay. And what? Mm-hmm. Okay. What about now? Mm-hmm. Env, but we don't need this, I think. Env, because we need env file, and env file is not present here, I think. Yeah. Yeah, because env file doesn't exist. Python.env get started. We need something simple like this. Yes. .env, and we need, sorry, we need, this is not useful, this is useful, this is not useful. We need from here mghost, mgport are required to be there, and we don't have, but it's actually not relevant. Yeah, but I'll just put it there to be mghost equals localhost. Do we need to be, that's also a string. 7. Okay. If we do here, boom, boom, true database, boom, we have that dataset generator. That's gonna work, but we already did that, so now define mapping between, yeah. Config, parquet, local data. Ah, here we are. We have the stuff here. Yeah, I essentially did the same thing. Should have looked at this before. But okay, it didn't take too much to figure that out. But we did this, so I won't run it again. What is this? Image demo PNG. Ah, that's under. This is the demo. Okay, all good. Oh, nice. So, okay. Now we essentially get to the same result, but since we have things here, I'll just push that under load data memgraph. Let me just rerun this. This is Jupyter. This is Memgraph. Okay, what we need is Yeah, it's running, which means it's fine. All right. A bunch of files which have to be ignored. Python notebook checkpoints. That's also not here, so okay. Let me just create that as well. CMD, so this is actually wrong because this is Memgraph tab. Memgraph, yes, and here we have IPy notebook. Okay. Ignore. We have to ignore .IPy notebook points. Nice. Now we modified the IPython notebook, but we don't want to add that, so git add requirements env git ignore docker compose in memgraph py. Git dc, so we added this, we added docker compose file, we added importer, and we added requirements. Add local loader, add pure Python loader. Git push. Okay, now we have that on the repository, which is amazing. All right, let's finally get back to the domain, which is fraud. So as you can see here, we have the schema visualized here. So we have a policy which is insuring vehicle, insured with individual, insured individual, okay, injury on individual, claim payment, payee payer, on claim. So this is like injury, this is individual, this is incident, what actually happened related to this policy, and there is address, and you have, so obviously you can, this is a very simple model, super, I think, comprehensible, and it's quite easy to understand it. So basically one of the ideas is to, whenever you have a shared entity between for example individuals, if individuals share the same address and they are connected to some incident or policy, then that's a suspicion that policy, that incident is suspicious, because yeah, why would people on the same address do stuff like that? But it can be other things as well. This is just super simple like reasoning about what can actually go wrong. We have the query builder, so this should actually also run. There is some warning. Is injured with policy. Can I? Yeah. So the query is actually running. Query builder, policy, la 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 la. Insured with relationship, insured, node individual. So from policy to individual, that's like from policy to individual, okay. Is insured with policy. Yeah, so essentially you have a graph query from policy to individual, and you get 5 of these, and then you have a type printed out. So that's super simple. That's a bit related to the GQL Alchemy. So if you use GQL Alchemy, you can write these type of queries by writing pure Python code. You will have auto-completion and all these things in the IDE. But if you want to run a query, or just also GQL Alchemy supports the raw queries, so you can also run exactly this. Let me just maybe just to run this inside the lab, because it's equivalent. So if we go here, and we run this, boom. So we got 5 of these individuals which have some data points. So driver license true, first name Lindsay, last name Martinez, and la la la. So that's all fine. Moving into interesting area of potential frauds. So here we have a slightly advanced query. So individual, policy, insures individual, incident, claim. There is a chain of stuff. So there is a claim related to an incident. Incident is related to the policy, and policy insures individual. So if we run this, I can make this bigger. Okay, now we have this. Christopher has involved in claim. So claim is the. So we actually, throughout this chain of relationships, we ended up in people who are actually related to these claims. So okay. First, after paying history, we'd like to extract features each item. Feature store. So we have a couple of features, which is in the account, amount paid, in the account. I think in the account is count of individuals, amount, policy expired, policy premium, influence, number of frauds in the neighborhood, number of frauds in the community, embedding, and fraud. And okay, so we have this, and if we run, now we have get individual count. So we have a couple of Cypher queries which are, so we'll, for claim ID, we'll count how many individuals are attached, get amount paid, what's the amount that was paid, get policy expired. There is, that's some date. So get policy premium. These are essentially features which are extracted out of the whole graph. If we run this, we have the data load, test policy ID. So for this policy, we will print, what is wrong here? Why did this fail? 0, total amount paid 0. I probably have wrong policy ID. Because I generated a data set, so I have to change this to something realistic. And let's use it's here like CMD, and 5 is the VD. Visit data. Where is visit data? Ah, I forgot about the command I used. Yeah, that one. Format pandas, VD format pandas, okay. So 5 dataset data, and now we need what? I think we need the, sorry for jumping around, we need policy ID. Policy ID is questionable, so policy parquet collision 17. How to copy from here? That's regex, Control C. 17 FD. So 17 FD 3736 3736. 17 FD 00. Why this doesn't work? Test policy ID is policy expired. Let me get this query, get policy expired, so we can take copy. Let's go to Memgraph lab. Claim ID is that one. Policy expired has so these are the variables that have to be exchanged. Okay, claim ID we don't need. Aha. Aha. Claim ID, test policy ID, but how? Aha. That's the claim ID, not the policy ID. Yeah, okay. Claim. Okay, fraud, false, false. Let's find something which is true. Maybe page up, down also work. Oh, true. F0, A0, claim ID, F0, A0, 97E6, 7E6. Failed because we have extra parentheses here. Policy expired false. Aha, okay. Now this is working. Okay, we have to go back to here and change this to this test claim ID. Claim ID. Test claim ID. Now this should be working. Boom. Nice. So number of individuals involved 3. Total amount paid 0. Is policy expired false. Policy premium type U. Okay. Now we have, of course this failed. Okay, now we have the issue because we haven't run Memgraph platform. We just run pure Memgraph, which doesn't have these modules loaded. So we need to find latest Memgraph platform to run against. Okay, so this should be somewhere here. Memgraph platform. Memgraph platform tags 231. So I'll just replace under Docker. I'll just replace Memgraph platform. So we have to go here. We have to stop this. Docker compose up. They should pull the latest platform. Oh, no. Because I have to return back these two and then put platform. Because we are running platform again, so Docker compose has to be slightly changed, which is fine. While this is running, I'll just try to see for comments. All good, all good. All right. Yeah, we're gonna have to commit this Python notebook because we changed a bit. So we'll do that all together later. Good Git practice is to commit often. So let's do this. As long as we have this running, I'll commit git add docker compose git dc. Dc is alias for printing only changes. So we should be disconnected here, which is fine. Okay, while this is running, let's move a bit forward with this. So this will be possible to run later on. Hopefully, I think platform has all these things included. Yeah, okay. Python is quite big because it has all these modules loaded, and some of them are huge because of the Python modules included. So yeah, we have to wait a bit. Just check one more time here. So we have stuff here, it's all fine here, it's all okay here. Come on, come on. Hopefully my stream will survive because I'm downloading a lot of data. Maybe I can play Google Game White. How to run this? Ah, still not done. But I don't need black. I don't want black version. Oh, nice. Ugh. I'm super bad at this. Let's stop. Oh, it's still downloading. What the fuck? Oh, okay. Let's clean this up a bit so we don't need this anymore. This is also fine. This is also fine. We need YAML poetry. Boom. Okay. Hopefully we have Memgraph up and running now. Yes, there is 0 stuff in the database now. Let's import data. Boom. It's getting in there, so we can actually commit git git push. Okay. Memgraph is still loading. Okay, nice. Should be in there. Yes, all good. graph schema, generate graph schema. Boom, we have the graph schema. And now go back to here. No. Now we might have wrong data again. So this is fine. This is loaded, but this might not be the case. Yeah. Because I have to redo it, I think. Don't run this because that will re-import things. In claim. We can actually reuse the claim ID from here. Nice. Claim. Boom. Nice. Now we load everything here. Nice. Okay. And get claim vector embedding, get embedding. How is that done? So that's the embedding. Claim ID. When we run this embedding, it will actually create node2vec embeddings for this claim, and this is generated here. And yeah, if we run this, why is this failed now? Probably because of test policy ID. Is this really a policy? Because we are, yeah. Because this is claim ID, I think this is wrong. Because we are fetching claim ID, not the policy ID. Yes. Get claims. Where is get claims? Okay, this is actually working. Okay, and now we scikit-learn. Okay, we don't have scikit-learn. We have to install that. So this is just we took all these features, and now we just run a logistical regression on this training data, and we're gonna train the model, and then we're gonna see some results. But before that, we need IPython notebook is here, and we need scikit-learn. We'll install scikit-learn. Okay. If we run this, Seaborn is also not here. See, Seaborn. Seaborn, okay. Boom. We have nice. Okay. Label predicted, label actual. So we have false, false, 266, which is fine, true, true 8, and we have one which is predicted true, but it's actually false, so only one. From all these examples, we have only one missing classification, which is amazing. To ensure faster processing, Memgraph represents the make analytics. Once data is inserted, we can create these triggers. I think that's gonna also work. New claim ID. Now this will fail massively. This will add some new data in. Hopefully it's gonna fly. Now we have new features. For that claim, which is new, we have fraud prediction false. So we use that generated model to actually run some fraud detection. Okay, this is amazing. We made all the we have some warning here, but doesn't matter. We made all the example pass. So I'll actually commit this file because we slightly changed it. I think claim ID is actually claim ID. So yeah. Get st, we have that change. Get diff. We changed a lot, but yeah. Okay. Fix. So test claim ID. Okay, that's now pushed, and let's just polish a bit. So we not need this. We just need insurance. Need insurance fraud here. Dataset, la 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 la. Okay, we'll just put some description here, and so we need Docker compose, and we just can run it with that, and we'll just add also requirements file. Yeah, that one thing which should also change. Pip freeze. Bunch of requirements here. Should be fine. Let's just try to create another. I will leave it as is for now. What? Ah. How did I change this file again? No idea. But yeah. Okay. Add all to the requirements. Okay, get push. If I reopen this again, All right. Nice. And we'll just remove the title, change the title in to make it more clear what is going on. And probably we can just add we can just push that as I'm polishing a bit the GitHub stuff. We can maybe just polish yeah, this is not I'll just make a screenshot of this and yep. Can I take a screenshot of this? We have that in the clipboard. How to export it? Okay, we have that screenshot. Nice. Schema, lab schema, lab graph schema.png. Okay. Screenshots, screenshots, screenshots. Yep. Lab schema, lab graph schema. We move that. Copy mg workspace code memgraph insurance fraud image. Select. Nice. Lab graph schema, and here we just do. That's also in the notebook. So an example how to do this. All right, we have a bunch of stuff here now available. Let's go to this branch and just try to Ah, of course I did. Fixing the readme image. Let's go one back. This should be now fine. Nice. Okay, insurance fraud detection demo. It's a bit better now. It has a bunch of these things. We can load for multiple things. Yes. Okay, I'm gonna stop here. I'll just wrap up the git co master, which is fine, and then just go to pull request, polishing, ready for review. But I'll just merge this as is, so squash merge, polish the running. Add this, add pure Python runner back to the platform. Let's also add platform. Test claim ID. Boom. Squash merge, delete this branch. We don't need that branch anymore. Under insurance fraud, now we have slightly better repo. If we go here, pull origin master, all right, we have that. Git branch minus the polish. Okay, only master. Get log. There is a clean state here. Amazing. Okay, that demo is a bit more polished now, which is amazing. Okay, hopefully you get the point. So we had, let me go back a bit. So we had two examples, which was card fraud and insurance fraud. Basically, in the first case, in the card fraud case, the idea was to run graph traversal to get common point of sale device where the card was compromised. With insurance fraud, it's actually a bit more complex model, but the idea there is to combine machine learning features and graph features to get more accurate fraud detection results. All these or both of these are available under Memgraph GitHub account. So if you go under card fraud, okay, let's go back here. If you go under card fraud, there is card fraud example, which can be easily run by Docker Compose. Out of the box, it's nicely packaged and everything works. While insurance fraud is a bit different. It's not that polished yet, but it has everything required under this repo, and it's fairly simple to run. Okay, amazing. So that was all from before. I just rerun stuff and comment a bit. Let's now switch to something completely new. What time it is? 12. Still feeling good. I'll just grab some water. Be right back. And back. And now I took off my hoodie, so it's gonna be amazing. Anyway, let's get back here. So insurance fraud is done. That's all fine. We don't need these, don't need these. Okay. But I think I'm gonna just comment on this and try to run it for the next time, because yeah, there's a bunch of stuff and it's, I think, fairly simple. So I'll just comment on this blog post, and maybe for next time I'll try to run these things, or yeah, maybe some other time. We'll see. Okay, anyway, fraud detection on graph analytics. I think this is fairly similar, because it uses like graph features to actually detect fraud. Just to verify, combining machine learning, graph analytics, model performance and compromising. Yes. Graph clustering, boost your performance. And data, yeah. Yeah, these are also some kind of claims. Yeah, that's, I think, fairly similar to the insurance. Claim is fraudulent or not, yeah. But it's not insurance, it's just healthcare claim. So maybe it is actually insurance, just to... But yeah, it's, I think this is almost exactly the same, yeah. The same thing can be applied. Node vertex, now there is simple stuff. We are loading that from the source and target. I had one live stream where I, once you have a network X graph, it's very easy to load that graph into Memgraph. So and that's also GQL alchemy. So degree, closeness, centrality, close and central node is to other nodes. Yeah, eigenvector centrality, that's another metric. Captures centrality for a node based on the centrality of its neighbors. Okay. And page rank. So here all these things are explained a bit more. And then we have these functions. We calculate. Yeah, for each claim, I think there are these features calculated, and then we do clustering with Luan, la la la. Here are the clusters of things, modeling results. The following table contains for each scenario using the best model on the validation set. And where? Now comes the ultimate question. Does the network representation of the analog business use case bring really strong and robust value to the model? Figure below. Yeah, I'm not sure if this was actually proven that these models are accurate, so... yeah, where is the code for this? So, Kaggle, healthcare provider. Modularity, one method. Yeah, that's the Kaggle dataset. Code can be found here. What is this? Yeah, that's only Plotly. Yeah. think we should actually run stuff here. But okay, this is just explanation, but we have to run the same stuff, but it's fairly similar to the previous example, so I'll just stop here. Okay, any questions? Let me check the channels. Group. Everything's still working, so yeah, okay. All right. Yeah, just to wrap up, so we showcased more or less 3 types of fraud, but 2 of them are fairly simple. So there is card fraud, insurance fraud, and healthcare or provider fraud. But that one is fairly simple. So you can use network graph traversals to get insights, but also combine graph features with machine learning models and techniques to get more accurate classifications and save some money for your business. Next time we'll see, maybe I'll go more into the fraud topic, maybe I'll cover some other use case, maybe I'll do something completely different on the C++ engineering side, we'll see. Yeah, thanks for watching, have a great rest of the weekend, and yeah, see you next time. Bye bye.